So what happens when your newest coworker is an AI? And I'm not talking about some simple chatbot. I mean an AI that can manage your company's finances or its entire cloud infrastructure. It's a fascinating and, an incredibly high-stakes question. Today, we're going to dive into a paper that proposes a really powerful way to manage that exact risk. Right. Let's actually think about that for a second. Imagine you have an AI employee, and its job is to optimize your cloud spending. What is stopping it from accidentally deleting a live production database? Seriously. Or what about an AI in your finance department making an unauthorized, totally irreversible payment? This is the core problem we are all facing as these systems get more and more capable. And this is exactly where we slam into what the source calls a hard engineering gap. See, for years, AI governance has been all about principles, ethics documents. And those are great, but they're advisory. They're just suggestions. When an AI can actually do things in the real world, suggestions just aren't going to cut it. You need guardrails, not guidelines. This really highlights a massive shift in thinking. The old way, it was all about audits and reports after something had already gone horribly wrong. But this new approach, this runtime enforcement, it's all about preventing the disaster in the first place. It's literally the difference between a post-mortem and a seatbelt. Okay, so how do we build that seatbelt? Well, the paper's answer is a concept they call verifiable governance, and it's a pretty revolutionary idea. Let's take those principles out of some dusty PDF on a server somewhere and turn them into active, executable code. And this is it, the Verifiable Governance Architecture, or VGA for short. You can think of it like a mandatory checkpoint for any action an AI wants to take. Before it does anything, it has to pass through this checkpoint. The checkpoint checks the action against a set of hard-coded rules, and, this is crucial, it creates a tamper-proof record of every single decision. So how does this thing actually work under the hood? Well, the whole architecture is built on 3 key pillars that all work together to create this enforceable safety net. So those 3 pillars are a policy engine called the Watchdog, a system of agent seniority that works kind of like a corporate job ladder, and an immutable evidence store for logging everything. Let's kick things off with the Watchdog. All right, first up is the Watchdog. The absolute best way to think of it is as a security checkpoint for every single AI action. Before any AI agent can use a tool, doesn't matter if it's sending an email, accessing a database, or executing a payment, it first has to get its request approved by the Watchdog. No exceptions. And here's the most important principle, the absolute core of this whole thing. The Watchdog's default answer is always no. If it's missing information, if a rule is even slightly unclear, or if for some reason it can't log the action, the request is denied, period. This fail-close approach puts safety above absolutely everything else. The second pillar, agent seniority, it builds on this safety-first idea. Now, this isn't about how smart an AI is. It's a governance control. Just like in a real company, right? A junior employee can't sign off on a $1 million deal. So here, a junior agent is basically read-only. A professional agent can draft up proposals, but only a senior professional agent can actually execute a high-risk action. And even then, it needs a co-signer, either another agent or a human manager has to approve it. And that brings us to the final piece of the puzzle, the immutable evidence store. This tackles a really fascinating problem the paper calls governance hallucinations, where an AI might just claim it followed the rules, even if it didn't. With VGA, we literally don't care what the AI says. Compliance is proven only by the verifiable, hash-linked log created by the Watchdog. It becomes the one and only source of truth. So, okay, why is all this so important? This isn't just some academic exercise. This is about making AI safe enough to actually use in the real world, in these high-stakes environments where a mistake can have really serious consequences. And a huge piece of that puzzle is compliance. I mean, governments all over the world are rolling out new regulations for artificial intelligence. An architecture like VGA isn't just a nice to have. It gives you the technical machinery you need to actually prove you are complying with these new laws. And this isn't just some vague claim. Just look at this direct mapping to the EU AI Act. The law requires record keeping. Well, VGA produces an evidence_packet for every single decision. It requires robustness. VGA's fail-close design is the perfect answer. The key point here is that VGA gives you concrete, auditable proof that directly addresses these legal requirements. Okay, beyond just compliance, there's a really powerful business case here too. Good governance isn't a cost center, it's an investment.
And specifically, it's an investment in reducing catastrophic and very, very expensive risk. The paper grounds this in some hard data. Get this. Studies show that the average cost of a major cybersecurity incident is over $2 million. And what's often the root cause? You guessed it. Things like misuse of access and privilege abuse.
This is exactly what VGA is designed to prevent. By enforcing principles like least privilege, which just means giving an AI only the absolute minimum permissions it needs to do its job, it hardens the system against the very failures that lead to these multi-million-dollar disasters. It enforces the rules right at the tool boundary, before any damage can possibly be done.
So what does this all mean for the future? Well, as we move toward these hybrid organizations where humans and AI agents are working side by side, a system like VGA provides that absolutely crucial foundation of trust.
So if you take away just 4 things from this, let it be these. First, governance becomes executable code. Second, the default posture is always safety first or fail close. Third, evidence is verifiable, which means we can finally eliminate those governance hallucinations. And finally, risk is managed through a really clear seniority structure. Now, it's really important to be clear about what this does and what it doesn't do. VGA is not a solution to the huge, long-term philosophical problem of AI alignment with human values. But that's not its goal. What it is a pragmatic critical engineering discipline that gives us the enforceable constraints we need to safely deploy the powerful AI systems we have right now, today. Which leaves us with one final thought. To work effectively with these AI agents, we have to trust them. But not a blind trust, a verifiable, evidence-based trust. And maybe, just maybe, a system of clear rules, strict enforcement, and provable accountability is exactly the foundation we need to build that trust with our future AI colleagues.